This is AP Calculus Lesson 3-1. We're on our new unit. This is what it looks like. There are errors here. This should say self-check instead of fix-up. I will have my TA fix that. Thank you, Arrow, again. All right, so we have this paper in front of us. Vocab. So what does height mean? That means it is the y-coordinate. Coordinate has two O's in it. It's the y-coordinate. So if I come out here, by the way, everything now is color-coded for this unit. Height is always going to be in blue. So the height here, if I just have a random point, the height over here is going to correspond to whatever y-coordinate I have. The height over here is going to be whatever y-coordinate I have. I mean, that's pretty easy, Mr. Sindel. We've been doing that since Algebra 1, way back when we were in kindergarten. I don't know when you took Algebra 1 or Integrated 1 for Rochelle. But yeah, y-coordinate, easy, that's the height. Slope, we've talked about that a little bit. Slope is always going to be in red from here on out. And slope is going to be, the tangent line, right? It's the slope of the tangent. So it's, if I was looking at those points, all of a sudden I'm looking at the slope at that point, the slope at that point. And I haven't checked the ability if I have lines. Do I have, oh, I do have lines. How exciting. So let's undo. Let's see if I can, oh yeah, this software is pretty nice. And can I then move it around if I hit escape and then drag this guy? Okay.
Can I see the logo though to see if it's a ripoff of anything else?
The logo of this one?
Yeah, or the icon.
PDF expert, it looks like that.
I'm not noticing any ripoff. I mean,
this is a paid version. It's like $90 for PDF expert, or $70 or something like that.
Okay.
Yeah. So that's a tangent and concavity. That's this new idea. I'm gonna always do concavity in orange. The reason I choose orange is because it's in Desmos and it's also in GeoGebra, and I have the orange here. So concavity, that's if it's a smiley face, or if it's a frowny face, or maybe you want to think of rainbow. Last year we were all positive. It was 6 girls, so it was smiley face and rainbow. So the way that I show that on the graph is by kind of doing an arrow from wherever I see a curve. I see a curve here. This is concave up. So let's write that.
Wouldn't concavity be also as minimum and maximum?
Yeah, it does happen at minimum and maximum. That's an important point to make. Technically, minimum and maximums are actually defined by where the slope changes. All of a sudden, I have positive slope, and all of a sudden, I have negative slope. The change between positive and negative slope is where it changes concavity. So if you look at the slope, you can tell where it's concave up and concave down. You touched on an idea that we're not going to get to until 2 or 3 more lessons away. But yeah, so analyzing where it's concave up, concave down. Over here, it's concave down. So all of these are concave down, all of this is concave down, all of these are down arrows, all of those are down arrows. In fact, this type of function is concave down, even way down here. This is always concave up, which means somewhere, and actually it happens to be at x equals 0, it changes concavity. Right here, we don't know if it's concave up or concave down. You have a DNE point, I believe, or you have some weird thing happening there that switches concavities. But concave up all over here, concave down all over here. We know about positives and negative slopes. We're good.
Shouldn't it be concave up still until like the height?
Until
like the center of the concave down.
So you're thinking that it should be concave up right here?
Yeah.
It's still concave down right here because this is still part of a rainbow. You can see that this is still a rainbow right here, still a rainbow, and then all of a sudden this is the point that it changes. Yeah. It's a little bit hard to kind of twist our thinking to think like that, but yeah, this should be all concave down over here. This should be all concave up on the left. All right, and don't worry, today's lesson is just looking at those and analyzing. So height. There are 3 graphs that we need to read, F, F prime, and F double prime, as you clearly see. I'm going to give you a graph of F, so the normal thing that we're listening to. So height. And height is going to be in blue. Height is just F, right? If I take F, I know what the height is. If I say F of 3, that is the height. It's pretty easy. It'll change once we talk about F prime. But right now, height is F. So let's look at the height of A. F of A. What is F of A? Is it positive? Is it negative? Is it 0? Those are the only 3 things I really care about. What is the height at A? Not quite. It's right on the x-axis, so it's equal to 0. What about f of b? What is the height at b? Positive, negative, 0? Shout it out.
Negative.
It is negative. It's less than 0. What about f of c, the height at c? Yeah, positive, greater than 0. And finally, ran out of room, but f of d, the height at d is now going to be positive, negative, 0? Positive. Perfect. All right, slope. Slope is going to be represented by what do you guys think? If I had f here, this is going to be f prime. There it is. F prime. All right, so all these change to f primes instead of f. So I'm going to squeeze this over more to the left so I don't run out of room. What is the slope at a? Oh, lag. What is the slope at a?
It's negative.
It's negative. It's whoops, I don't know why I wrote equals. It's negative. It's less than 0. And if I come back over here to my fancy line tool, it's negative right there. If I drag that, you can see that the slope of that is clearly negative. All right, what about the slope at b? It does equal 0, yep. And because of that, I'll show you the picture. Whoop. It's a flat line right there. What about the slope at c?
Positive.
It is positive because if I come over here, that's about the slope, and I move it to the correct spot, right about there. Yep, so it's positive, greater than 0. And what about the slope at d?
Negative.
It is negative. And just drawing the picture, I have a slope that is negative. All right, concavity, what is that going to be represented by?
F double prime?
It is f double prime. We finally touched on our second derivative. You can take the derivative of the derivative and you get the second derivative. It is how it works, yep. So if I take the derivative of the derivative, f double prime, what is f double prime of a? What is the concavity at a? If it's concave up, it's positive. If it's concave down, it's negative. It is positive. This is greater than 0. Because this is concave up. I'm just going to do an up arrow on my graph. So write an up arrow on A. What about f double prime of B? What is the concavity at point B? Someone new, shout it out. Rochelle just did the last one.
This is just 0. So it's neutral-ish.
0, neutral-ish.
No. Oh, no, it'd still be positive.
It is still positive.
Still
Why?
a positive area.
Yeah, it's still like the smiley face down there. Do you have a question, Rochelle? Okay. Ben, concavity at C.
Less than 0.
It is less than 0 because this is now concave down. And finally, the concavity at D. Someone, anyone.
Also negative, yeah.
Also negative because it's concave down. Less than 0. Perfect. All right, so height, slope, and concavity, they mean different things depending what you're talking about. If you're talking about the graph of f, all of this applies. If I'm talking about the graph of f prime now, it changes. The height of this graph of f prime is no longer f. It is what? It is f prime. The height over here represents f prime. So f prime of a. What is the height at a? Even though it's f prime, I'm still asking for height because this is a graph of f prime. It is negative. I'm going too fast. I realize that because this is a hard topic. How do I suddenly go from f to f prime? How does that change? You're still talking about height, so this height right here is an f prime representation. It's not f anymore. What about f prime of b? What is the height at b?
Positive.
Is it 0 or positive?
Because it's on the y-axis, right? But on the y-axis,
Well, the height is greater than
there's
Yeah.
not it.
0. X is 0.
Yeah, because we want to say, oh yeah, well this is f prime, but it's a graph of f prime. So this thing that I'm drawing right now is actually the concavity. So just the height on the y-axis, this is positive, it's bigger than 0, so this is bigger than 0. The height at that point is f prime. Because it's the y-coordinate, right? The y-coordinate is positive. The x-coordinate is 0, I agree. But the y-coordinate is greater than 0.
Also, the height is always on the y-axis, right?
Yep, always correspond to the y-axis for the height. Good way of saying it, yeah. And finally, f prime of c. How do I say this? F prime of c, using another word. Yeah, that's another way of saying it. The slope at c. And in terms of this graph, it's not. You can't use the word slope because it's still height. It's the height at c. Height of c is what? Less than 0. All right. Finally, we go to slope. Well, I shouldn't say finally, but slope. It's going to be represented by what? Shout it out. F double prime. So what is the slope at A? What is f double prime of A? It is positive, yeah. Because if I come over here, change my color, it is positive. All right, what about the slope? How do I write the slope of B? What do I write again? F double prime of B. What is that thing?
The height of f double prime.
Not quite the height because we're in this new category.
The slope.
Yeah, so the slope at B, what is that going to be? Yeah, 0. It's equal to 0. What about f double prime, the slope at C? It is going to be negative. Because, again, we have this line that comes down here. All right, what is concavity going to be called?
F triple prime?
It is f triple prime. Oh man, going to the next level. Inception.
But what if you have like 10? How do you know how many it is?
Yeah, it's hard, right? Here's
You have to count them.
in all of the field of calculus, yes, you might go to the 3rd and 4th and 10th derivative, but in AP calculus, we don't do that. In fact, this is actually the name of f triple prime has a cool name in physics. They call it the jerk. Like, how much are you accelerating? What is your acceleration of the acceleration? If your jerk is really high, you suddenly you just took off because your acceleration was accelerating really fast. So this is the acceleration of the acceleration. What is your jerk? So go ahead and write this down. This is called jerk. You don't need to have space down here. We're not going to do it. This is called jerk. And in AP calculus, we don't care about jerks.
Because you're rude.
Yeah, they're rude. We don't care about jerks. So don't worry about concavity. You can cross it out if you want.
Why don't we get to the concavity?
What was that?
We're not doing it.
Why wouldn't we do it?
Because we don't ever do f triple prime or f quadruple prime or f
So it's always on f double
quintuple. Yeah, just stop at f double prime. You're good.
But
Not for now. For all of this year.
the more the merrier, right?
Wait.
The more prime symbols, the merrier.
I mean, if you want to, but think about this too. When you take the derivative of the derivative, think about quotient rule. If I take the derivative once, I have a new quotient, which is even uglier. If I take the quotient again, it's even uglier. By the time I take it a 3rd time to find jerk, your quotient rule has been applied 3 times. It is going to be an ugly, ugly number unless it boils down to 0, because it might boil down to 1, and then you take the derivative of 1, it turns into 0. If you're lucky, it'll turn into 0. If you are in the majority of cases, like 99.99% of the time, it's going to be an ugly, ugly fraction. We don't deal with jerks.
So you're able to, but you just don't feel like doing it.
That's a good way of saying it. And also, they don't ask for it on the AP test, so it's not worth teaching you. And I don't feel like it's worth teaching you ever, just because I didn't even see it in college.
Do
So
you think it would take longer?
it would take not very much longer. It's more algebra. I would have to teach you guys some new tricks to get rid of some interesting fractions. All right, the graph of f double prime. What is height represented by?
F double prime.
F double prime. I don't know, I did 2 f's there, but f double prime, which is cool too, right? So if I have a graph of f double prime, the height is always whatever it tells me right here. That's the shortcut. Height is always whatever it tells me. If it told me it's a graph of f double prime, the height is f double prime. That's the shortcut. So what is the height f?
What if they don't tell you? How would you know?
If they don't tell you, then it's a horrible problem and you should ignore it and then pretend it didn't happen. They should always tell you. Yeah, if they didn't tell you, it's a mistake on their part. On the AP test, on Mr. Sindell's worksheets, I'll always tell you. So what is the height at A? What is f double prime of A?
Smaller than 0?
Smaller than 0?
No, wait,
Positive.
bigger.
Yeah.
Bigger than 0, yeah, because this y coordinate that corresponds to A is greater than 0. Perfect. And how do I write the height of B? On the
Double prime of B.
f double prime B. Yep, f double prime B. Ben, our arrow, what do we think? Yeah, equals 0. And then Ben, you do this last one. Tell me exactly what to write.
F
Verbatim.
double prime of C is less than 0.
Less than 0. Perfect. And again, this slope is going to be f triple prime. That's our jerk. We don't care about him. Don't worry about slope.
And then F quadruple prime.
I don't even know what the meaning of that is in the physical world because I can do the acceleration of the acceleration and I can kind of understand like if I just step down really hard on the gas pedal, my jerk is super high, but like the speed at which I press down on the gas pedal to accelerate the acceleration, like you've gone into a world that it doesn't even really make any sense. Just don't even worry about concavity on the graph of f double prime.
Alright, what's the guy's name from Back to the Future? Oh,
Marty McFly
yeah, we should call
or
him.
Doc? Wait, why should we call him?
Because, like, the car is going
Oh, they only went to like 89 miles per hour, didn't they?
Well, it's like unheard of at that time, probably.
It was not. That was
Maybe it
30
wasn't.
years
I
ago.
don't know.
80 miles per
years
hour was
ago.
unheard
Hold on,
of.
we need to know this. How fast did Back to the
Of course, what about that?
car
Well,
go?
like, in the movie, it's
I was 88, not 89. Okay, I was off.
You're off by one.
You need to know that.
I see people going that fast on the highway.
Yeah.
They're traveling back in time.
All right, that was all I had for the notes. There's no backside. Go ahead and write your summaries now. That concludes the notes. Say goodbye to the future years worth of people watching AP Calculus. Say bye.
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 Bye.